Okay, welcome back. This is chapter 21 and 22 in the big book about the network file system, and so the native file sharing protocol, and then the comparable one for Windows called SMP. Okay, so network file system, NFS, was originally designed by Sun Microsystems, the people who made Solaris and all the rest of that stuff, as a way to work with diskless workstation. Their idea was they would sell you this box that had no hard drive, and because you didn't really need, well, all you need to be able to do is process. And so what you would do is you would mount a file across the network, and so that way if the machine got damaged, well, you just swap the machine out because none of the stuff was stored there. It's really cool for security because even if somebody came in the middle of the night and stole the computers, right? They stole the computers and took them home, there would be no data on them. Pretty cool scenario. Anyway, back in the day, that's what it was intended to do. Of course, when it was written by Sun Microsystems, it was a kind of proprietary thing, but then they kind of switched over and said, hey, this is pretty cool. Now it's a public standard. Okay, so at the beginning, let's talk about what file services actually means. Well, the ability to read and write to files across a network. Yeah, that's one way. But let's look at it from another perspective. What we really want to do from a programming point of view, we want to make it relatively transparent. If I use the open command to open a file on my hard drive, I want to be able to use the exact same open command to open a file on the network. I don't want to have to learn two different types of how to open a file or read a file or close a file or write to a file. I don't want to do that. And so they wanted to make this thing as transparent as possible so that you after the initial setup, you could kind of sort of close your eyes on whether or not you were writing to an honest-to-God real file or writing to something across the network. Now, a scenario exists that it exists in just a plain old disk file, and that is what happens if two people are trying to write to the same file simultaneously. Now, it doesn't happen that often if you're talking about a disk, that's on your PC. I mean, yeah, you could have 5 or 6 users simultaneously, but it's not that common. But on the network, yeah, it's fairly common. So somebody has to play traffic cop. Somebody has to do conflict resolution to figure out who's doing what. And so the file services, in addition to trying to be as transparent as possible, have to play traffic cop. They have to do security. They have to do auditing. They got to do all this stuff. Okay. So basically there are several options of how to do this in the real world. The first one is NFS, which is what this topic is all about. So chapter 21 is on NFS. This is like the native technique that Linux and UNIX uses for sharing files across the network. Okay, cool. There's another one called SMB, Server Message Block. Kind of a horrible name. But that's the Microsoft version, and it is practically the same. I mean, from a concept point of view. Mechanically, of course, it's not. But practically the same from, a concept point of view of where you try to be transparent and all the rest of that stuff. And the next one would be a storage area network. And the storage area network basically takes all the guesswork out. What happens is I plug a card into my machine, and then I run a cable to a hard drive, and then the hard drive does its thing, and other machines can get to that same hard drive. So for all intents and purposes, it looks like my SAN disk is actually one of the disks on my machine. So that makes it even more transparent. But that, costs money. And then there's other types of distributed file systems. There's one called Cluster FS, and there's Ceph, and big data uses an awful lot of these kinds of things. And distributed file systems are designed so that, I don't have to have everything. I mean, can you just imagine, for example, census data? Maybe you don't have all the census data in one giant system. You have the Texas census data in a server in Texas, and Louisiana census data in a server in Louisiana, and you just kind of make it look like all these things are one giant disk. So there's 50 disks there, one for each one of the states. In reality, to you, it's a distributed file system. In other words, you can't tell which state you're going to while you're just perusing the file system. You descend into a directory, magically you just move to another location, but you don't know. Okay, so distributed file systems are pretty cool because it allows you to geographically space things. I don't have to have one giant anything anywhere. You can kind of imagine why the big data people kind of like distributed file system. And then, of course, cloud-based. That's always an option where, I just put stuff up on the cloud and everyone who has the right kind of permissions can get to it. No big deal. Okay, so the next thing we need to talk about is what's called stateful or stateless. Let me explain what that means. Basically, what this question is, whether or not a network file, some sort of a networking system, is stateful. Stateful means the networking system knows which file I have open. It knows. I'm not talking about my machine. I'm talking about the network machine. In other words, I have two machines. I'm the client over here, and over here is the server. The server knows that I'm connected and knows what I'm doing. That is stateful. Now, as you can probably imagine, there's some problems with stateful in that it doesn't scale very well. I mean, if I had 40 users, well, it'd be perfectly okay for the file server sitting over here to maintain, okay, there's 40 people talking to me and they're connecting to these directories and looking at these files and somebody's reading and somebody's writing. It wouldn't be that bad. But 1,000? More? All that housekeeping, that keeping track of all that state would probably consume more of the server's processing power than it would be for just transferring files back and forth. Okay? So there's some disadvantages in a stateful kind of a thing. Okay. Now, here's a problem with something being stateless. Let's say I don't really know. It's like, no, I don't care. You, client, have to keep track of what file you're looking at because I'm not going to do it for you. Okay? That kind of makes sense. But let's imagine. So that spreads the load. It makes each one of the clients responsible now. Now here's the issue. It's more difficult to determine collisions when two people are writing to the same file at the same time because that decision is being made out here in the outside edge, not in the center where the files are. The second one is, heaven forbid if the machine crashed or even the client machine went down, I would basically have to go and say, look, I was kind of halfway in the middle of something here, and can you help me out? Can we figure it all out? So it makes recovery really, really difficult because the server has to negotiate with the client about what's going on, which is really rough. So yeah, each client does their own thing, and good luck. So that's not very good. But you got to admit it spread the load. Okay. So performance. So NFS at the beginning did not use. This is kind of, hey, I assume you've taken a network course, so I'm gonna talk about these terms as if you know what you're talking about. If not, that's okay. You can read the book. So NFS didn't really use TCP at layer 4. It used UDP. Now UDP, this is almost the exact same conversation we just talked about with stateful versus stateless. Okay? Here's how it goes. If I'm using TCP, then the network takes on some responsibility of making sure that a packet didn't get messed with. If a packet got messed with, the network says, hang on a second, that packet, checksum didn't work, and I believe it's corrupted, so let's just ask for that one a second time. Okay? The client doesn't know anything about this. It all just happened behind the scenes. If we're using UDP, then UDP is a lot faster because it doesn't have to start up a connection, doesn't have to tear down a connection, but it doesn't keep track of, wait, you're sending this too fast for me, I need you to slow down, or hang on a second, I didn't actually get that. All that responsibility is now taken upon the client, okay? Not the network. The network says, hey man, you told me you wanted UDP, I'm going to give you UDP. If there's something wrong with that, that's your business, not mine. Oh, a packet got corrupted? Not my problem. It's your problem now. So UDP is faster, but you have to take on responsibilities. Now you got to remember how this thing was originally built. It was originally built for local area networks on a diskless workstation where you can pretty much well guarantee, pretty much well guarantee there's not going to be an awful lot of ash and trash on the network. You're not going to have an awful lot of noise and a lot of contention. You're probably not going to have, routers that go down and stuff. So, in a network environment where things are fairly robust and don't fail very often, using UDP was a fantastic idea. Cool. Okay. As you can probably imagine, that didn't last very long, and we'll talk about that again in just a minute. So the next thing we need to talk about is how to deal with security. Who's responsible for checking to see if I have read permission or write permission? Is it the server that does that, or is it the client that does that? Well, typically, you use some sort of directory services. Now, when we demo this, there's an upcoming assignment where you're going to have to do this. I'm not going to ask you to install any type of directory services or anything like that, So we're just going to we're going to skip that part. But in real life, I don't expect my clients to be the one that decides who I am, right? Come on now. Each client says, "Hey, I'm Bob," and the other, and so that's it. The client says he's Bob, so that's good enough for me? Really? That's all it takes? Wow. So yeah, there's some security issues with the way that how NFS could have been set up. So typically the client should not be the one who declares, okay, I have permission. The client makes that decision? Wow. Okay. So NFS typically lets higher level utilities, higher than it, figure out what permissions are, and encryptions for that matter. If you want to encrypt something so NFS originally wasn't intended to do any of that. They basically said, hey, look, all we're doing is making a file that appears on the network, pretend like it's here, and if you want to do something else, that's your business. Okay? That was the original intent. So, stateful versus stateless, kind of a strange decision at the beginning. Performance, yeah, again, kind of a strange decision at the beginning. And security, yeah, kind of a strange decision that they made at the beginning. Okay, so on page 794, they talk about the NFS approach. So we don't really talk about NFS as a protocol, okay? That's kind of weird. Because protocol kind of implies like a network driver or something that gets done like that. NFS is now baked into the actual kernel of the operating system. And again, this is kind of sort of for performance reasons. The idea is if I had to negotiate with a device driver who says, oh, thank you for your request, hang on a second, let me go get something, give it back to you, like that, kind of an extra middleman in between, it would kind of slow things down. Wouldn't you kind of see that? So the idea is that when it's baked into the kernel directly, then I can just make kernel calls and there's no middleman I have to deal with to be able to get the thing to work. Okay? So, why is it now in the kernel? Well, to tell you the truth, it was two reasons. One, it was getting pretty damn complex to do security outside of the kernel. And the second reason is no middleman makes it run a heck of a lot faster. Okay, so they talk about the history of this. So version 2, about in 1989, its goal was, hey, this is simple. I'm trying to make this thing transparent so you can just close your eyes and pretend like the file is local, and that's it. I mean, they didn't really care about security. They didn't really care about file locking. They didn't care about anything. It was like, hey, wow, isn't this cool? I'm getting files across the network. Okay. Version 3, 2 years later, they basically said, okay, we're going to do asynchronous writes. In other words, when I write to something, I'm not going to wait until it finishes to get the okay back. When I write a block, I'm going to say, I got your block, thank you, it looks intact, I'll let you know if there's a problem, and then it returns really quickly. That speeds things up. So the original one was okay. The second one meant, okay, we're gonna allow you to send me a request, and I'll let you know if the request is broke, rather than you hanging around waiting for the request to finish. Okay, we're coming up on the 15-minute mark, so you know how this works.